So, good day everyone. I'm Ronald Romeo. I'm here to discuss my topics that's all about hierarchical clustering analysis. So, we can start now. Hierarchical clustering is an alternative approach to k-means clustering for identifying groups in a dataset. In a contrast to k-means, hierarchical clustering will create a hierarchy of clustering and therefore does not require us to pre-specify the numbers of clusters. So, hierarchical clustering has an added advantage over k-means clustering is that its result can be easily visualized using attractive tree-based representation called a dendrogram. Clustering obtained by cutting the dendrogram at a desired level. Its connected component forms of cluster. So, hierarchical clustering will be illustrated using the AMC house data. If you like to replicate this analysis with the full set of features, since these features are measured on significantly different magnitude, we can standardize the dataset. Hierarchical clustering use distance metrics as clustering criteria. These methods does not require the number of cluster k as an input but needs a termination condition. There are two main of hierarchical clustering. First is agglomerative clustering, commonly referred to as agnes or agglomerative nesting works in a bottom-up manner. So it means observation initially considered as a single element cluster left. At each step of the algorithm, the two clusters that are the most similar are combined into a new big cluster nodes. This is a procedure interacted until all points are a number of just one of a single big cluster. The result is a tree which can display using dendrogram. Agnes or agglomerative nesting, introduced in Kaufman and ℕ𝔼𝕃 1990, implemented in statistical package example splash, use the single length method and the dissimilarity matrix, merge nodes that have the less dissimilarity, go or in a non-descending fashion, eventually or nodes belong to the same cluster. It's a bottom-up approach. Each observation starts its own cluster and pairs of clusters are merged as one moves up the hierarchy. So let's watch the video. How does agglomerative clustering work?
How does agglomerative clustering work? Imagine these data points in 2D space. In agglomerative clustering, you start off with each sample in its own cluster. Then you combine the nearest clusters, which are A and B. You can also depict this connection in the diagram on the right. This diagram is called a dendrogram and is useful in agglomerative clustering. To find our next cluster, we'll have to locate the nearest clusters once more. D and E, which are quite near to one another, form the next cluster. Now switch our attention to C for the next cluster. The AB cluster is very close to C, but how can we be sure? There are many ways for measuring the distance between the clusters, the most notable of which being minimum, maximum, average, and worst linkages. The distance between two clusters in a single or minimum linkage is the shortest distance between all data points in the two clusters. Assume that we are using minimum linkage, in which case A, B, and C form a cluster. Next, F forms a cluster with D and E. Finally, all of the data points form a single cluster. Obviously, such a broad cluster isn't what we're searching for. So, we may go back and choose the optimum clustering condition for our needs. This is how you cluster your data with agglomerative clustering.
So let's move on to the divisive hierarchical clustering. And divisive or Diana divisive analysis clustering is a top-down to clustering method where we assign of all observation is to a single cluster and to a partition of cluster to two least similar cluster. So this clustering approach is exactly opposite to agglomerative clustering. There is evidence that divisive algorithms produce more accurate hierarchies than agglomerative algorithms in some circumstances, but is conceptually more complex. In both agglomerative and divisive hierarchical clustering, user needs to specify the device number of clusters as a termination condition when to stop merging. So, hierarchical clustering is very useful way of segmentation. The advantage of not having to predefined the numbers of clusters gives it width on edge over key names. However, it doesn't work when we have huge amount of data. So that's all. Thank you for listening.